Product Manager at the Qt company for MCU software tools. And you might have joined our previous webinar on how to use Qt for MCU 1.0 release. In this webinar, we are running this joint webinar with Verolt company, where we're going to show you what has been done in porting Qt Quick application to a microcontroller using Qt for MCU. Before to go on deeper detail about that, we just want to give you an heads up about our company today. So the Qt company is a worldwide company that can help you and support you across the world, covering more than 70 industries with our expertise in supporting you, creating user interfaces around the globe. Just a quick introduction why we have done an investment in regard to microcontroller, because we have seen an increasing expectation on hardware regarding real-time processing, regarding low power consumption. So more and more embedded devices, they're required to consume less and less in their use cases, having an instant boot time of all the application running on embedded, and lowering the bill of material on your embedded hardware. So that's why, in order to provide even more value proposition to our product that today already provides, the one framework for all deployment story was missing one part. And that's why we've been deciding to invest our effort in providing to you one software framework that enable you to cover all the platform in the market. So mobile, desktop, and microprocessor, web, and microcontroller. So what we have been doing, we have been investing in a new product that is called Qt for MCU. And what is Qt for MCU? Is a software toolkit that allow you to create graphical user interfaces on microcontroller. And if you are already an existing user of Qt and you are using already Qt Quick, you will notice the benefit because you can reuse the same Qt tool and the workflow to develop for a microcontroller. You can save cost because you can reuse the same engineers and expertise and same technology across different families of devices. And you can, of course, improve your own product family, lowering the bill of material and the memory footprint, reducing the bill of material cost by moving to a microcontroller. If you are a new user, so if you don't know anything about Qt and you want to know more about running a user interface on a microcontroller, or you were using a different tool before, using Qt for MCU can give you and grant you an upgrade to a modern, stable, cross-platform graphical toolkit. You can reuse the same backend and C++ backend you have been using with different tools, also with Qt for MCU. And you can consider to have the benefit of having a scalable UI and flexible layout mechanism that allow you to scale the screen size and aspect ratio. So what you need to consider is what means Qt for MCU. Qt for MCU provides you a new graphic runtime that we are calling Qt Quick UltraLite that allow you to basically render on a microcontroller and use QML to build graphic front-end application directly using Qt for MCU. And as I mentioned before, if you want to reuse C++ backend logic you have been already implementing in your previous microcontroller application, you can integrate that directly with Qt for MCU. What is important for the people, they already know Qt and they are using, for example, Qt for a device creation. And this is a graph that allows you to understand the scenario you can face today. For example, if you are going to develop an application on a new platform, on a new Cortex-M application, what you need to consider is that Qt for MCU is a subset. So Qt Quick UltraLite is a subset of the normal Qt Quick, and allow you basically to reuse part of the code you have been already using for your Qt for device creation application. And based on this introduction, I hand over to Lars Konisch from Verolt that will start explaining you what has been done, importing a Qt Quick application on a Qt for MCU application. Thank you, Lars.
Oh, that was too fast. Hello, everybody. Thanks for joining. And before we go into the real meat, maybe perhaps a few words from our end about Verolt. It's a little bit selfish self-promotion. Verolt is a software service company, a fast-growing software service company. You see here, in January, we have been 15 Qt experts having in our development centers. May 2020, we expect to have 20. We have also quite some senior managers with combined development experience in automotive, industrial, and aerospace. So there's a good foundation to support software services topics around the globe. Of course, we have a strong presence also in Europe. Our headquarters is here and our customer support. So that's something to know for you. Our main areas are application development services from UI design, graphics, multimedia frameworks, porting and development of GStream aspects, for instance. We have done quite some topics around voice, sketch, speech, connectivity, and of course, last but not least, we're on BSP middleware development, be that Yocto Linux, Android, or any kind of RTOS is key competent in our end. There's also ECU development we can support, really the hard stuff, going down to C level things and functional safety topics we can support. We have also mechatronics, but that's rather not of that your interest today, I would suppose so. If you'd like to know more about us, we will be at the Embedded World this year, having a partner booth at the Qt company. So of course, there's also more to learn at our website. We will come up with some promotion together with the Qt company, a white paper coming out. This thing here is something to come, and we support also Qt company with other new topics which will be shown at the Embedded World. Of course, if there's anything you want to know more about us, just reach out. You find us via the usual means, also LinkedIn, etc. Now let's go into the foundation of our porting project, which when we did in September, October timeframe, the foundation of the porting from a Qt Quick application to Qt UltraLite, or Qt for MCU, was a Home Chef consumer electronics demonstrator we have been developing together with the Qt company over last year. And that was also a nice project, just to give you a heads up, an idea of that. So it was about 3 different deployment scenarios, being on a desktop scenario, and a mobile scenario, and an embedded scenario. And we used for all of that one design and code pipeline. So we used Photoshop and Qt Design Studio. We have been coming up with one unified Qt Quick architecture to deploy to all these platforms. But of course, on the one hand side, same brand identity and same code, but also different use cases and different technology being used. So the use cases in all deployments are slightly different or have different form factors. And we are also utilizing different technologies. Like we use Web Engine for playing YouTube videos on the embedded device. That's the cooking machine idea. There was WebGL being used to stream the camera output to a remote browser, for instance. We used WebAssembly for the desktop scenario to showcase the software as a service idea with WebAssembly, and also to share development statuses with the customer. And of course, also the complementary thing of a mobile app was also. And what we did is we took that application, Qt application, and ported that to Qt for MCU. It took us around about 4 weeks. And who was responsible for that? That was mainly Ravi, who's also with us today. And he will take over now for giving you an idea how that went and what he needed to look and consider moving forward.
Yeah. Thanks, Lars, and thanks, Michele. And yeah, so the idea was for the Home Chef application was to develop uh, for multiple platform. And so this platform was for the desktop, embedded, and mobile and web scenario. So in this slide, there is a presentation how the workflow was done for this and how our idea of unified architecture was propagated here. So as we discussed, the common tool chain what we have used is all the designs were done via Photoshop, and then with a new tool from Qt Design Studio, which was used to generate the QML and the assets, and finally the Qt Creator to manage the screens and the backend programming. So from the tool chain, what we Design Studio, we generated the images and the QML component. And this was for desktop, embedded, and mobile and web. So this was a quite interesting journey. Each one has some specific requirement, and the customization was required for each component to address various platform. So we generated the component and for various deployment, and we use the common assets, for example, the images and the backend logic to communicate via MQTT. Interesting part during the development, uh, we got opportunity to work with MCU too. So now, but Qt UltraLite, which is Qt for MCU, was having a Qt UltraLite, which is a subset of Qt Quick. So there was a difference, and so this was we need to implement certain changes in our QML code, and this is what we are going to explain you today. And here, embedded, so it was a derived deployment, so it was not exactly part of the unified architecture, but it is kind of a derived implementation. So I'll go to the next screen. So you can see this is purely a Home Chef application, the main screen where you have a recipe book and meal plan, and you can see the latest recipe will be coming from the MQTT broker, and you can select certain recipe and you can browse through them. So here is a list of recipes based on the category. So this is purely list in a list. So you have desserts, appetizers, and many other recipes. So here, so once you click on the particular recipe, so it will go through the different steps. What are those steps? And it will be fetched from MQTT broker, and it will be displayed onto your screen. Yeah, so this is this one. Yeah, so point is here, and the next slide here, what we are describing our experience with Qt Quick and Quick UltraLite. What are the differentiation here? So what we have gone through. Basically the first element is there is no rectangle border available in Qt UltraLite. So how we overcome by using basically we have used two rectangle, and the background rectangle was slightly bigger, so it gives the illusion of a border available. So that's how we have generated. And the Qt timer doesn't have some function, which is normally what we use, is this trigger on start. but here we had to explicitly call the start call. Similarly, list view has certain limitations. Horizontal scrolling is not available in list view. Instead of that, we had to use a flickable property, and yeah, for the horizontal scrolling. So basically, we have used the flickable. Another point is one thing you have to note it down, that text input is not available. So you may have to create your own custom type. As well as the pop-up is not available, but it is quite easy to create a pop-up management by using the Z order. So you can create a QML type and you should be able to create your own pop-ups. So that there's no limitation on that. So another most important also what we have seen is a font. Font takes quite a big footprint. So what we advise is to take a cautious call when you are using multiple fonts. So try to use a pixel size, and it should be fixed value. If you try to change multiple time the font size, you may end up increasing the footprint size. So these are the quite interesting element what we have seen during the development on the Qt UltraLite. I would request you to find the final version of the white paper will be delivered to you, as well as you can find the white paper what is available in following link. Okay.
All right, let's go to the code. I'm keen on seeing that.
So this was the code for embedded application, which was having recipes and other things. So I will just go through this was more on the backend side, how we handle a file operation or QR code generation or recipe book. And furthermore, about SNPs, so which was voice speech services, which was enabled. And now you can see the Qt resources, what we have done here. This
is the front end, right?
Yeah. So all the Qt components were developed. So all these Qt components are available here, and you should be able to see. So all these Qt components were QML components were developed inside Design Studio.
So, okay, cool. Do you have also the application visible?
Yeah. I'll just run this application.
Yeah, okay. Ah, there it is.
Okay. So I will just go back. So this is the main homepage, and you can see the latest recipe, and yeah, you can see individual recipe. So if you want to add to favorite, you can add to the favorite. You can, so now if you're decided to cook, so there will be a steps. So you can weigh the ingredients, then you can mix these.
Okay, so I understand this is the embedded UI, right? So maybe we go into an example where you ported this embedded UI to the MCU UI. Do you have an example on that end? Maybe we could go for the hamburger menu. That might be a good example.
Yeah, sure. So this moment, I would like to
So we see the PowerPoint.
Yeah, just a moment. I need to switch to other window.
Maybe just for the audience, while we have been developing that one, we always reuse all assets. So there was the assets, the design assets, for instance, they have been all created with the Photoshop and the Photoshop Bridge coming for Qt Design Studio. And those ones we just re-exported from with the Photoshop Bridge towards the towards Qt and Qt Creator with a different resolution, right? So just because the embedded the MCU device has a different resolution, and that was yeah, that was the best way of doing it, and nothing has there was no need to further modify the assets as such. So just reusing that and exporting that at a different resolution.
So,
okay,
so I would
camera
like,
out.
yeah. So I would like
Yeah.
to share the application what we have seen developed for embedded, and
Yeah.
here is available on the microcontroller. So we have a simulation mode here, so which we have added. So if you see, this is like looks like a pop-up, but we have created our own UI.
Okay. Looks
Type.
pretty performant. So
Yeah.
have you done anything towards whatever doing performance optimizations on that small hardware? So what kind of things you what tell us the one thing which was the most the biggest performance improvements you achieved on that MCU as we speak about that?
So if you see right now on the screen, the where dials or the progress bar which we are moving,
Yeah.
quite performant. So this was challenging, and since it is a low-powered device, so we had to use a common timer to animate multiple assets. So by doing this, we could create, by using the single timer, we could consume less computation power, and as well as for images, we have done a lot of compression and few more resizing so that the pixel budget, we stay within the pixel budget what we have. So these were the biggest performance gain for the microcontroller.
Yeah.
So yeah.
Okay, there's actually one question: how to integrate with C++ with your QML for Qt UltraLite. So that was also a question on our end, right? So how would you do that? How have we done that, and how would you do that these days? Maybe just a quick question. Yeah.
So we had very short time to demonstrate this application. So we took no backend for this application so far. So yeah. So having said that, but we have explored the recent version of Qt UltraLite, and we could send the data from the backend to front end. So we were able to generate the strings from the backend and send the complete data to the front end. So that was possible. One of the point what we have explored is on this STM board, we have migrated to the networking. We have added the networking feature with LWIP and MQTT. So we were able to establish the connection. Yeah, still we need to work on some of the aspects of communication to the internet and getting the data. So that is still work in progress. I think very well soon we will be able to release a new version where uh, the network and the MQTT will be functional, fully functional. So this MQTT and the network stack was not part of Qt. Yeah, of course, it is part of the microcontroller offering. So we have taken the LWIP and we have taken the MQTT library.
Just for clarification, my end, maybe asking stupid questions, Ravi, but was that about the embedded implementation, or was that about the MCU implementation you spoke about?
So we have done activity on the embedded application. So now our next goal would be the same thing should be done for microcontrollers. So there is no Qt modules are available for managing MQTT or network. So we have to add our own modules. So for that, LWIP and MQTT stack is being used.
Yeah.
So this is work in progress. Yeah, it is not completed, so I cannot show you.
No, that's a fair point, right? So that just people need to know that we haven't incorporated the communication part to the MCU deployment, just because for the sake of time, that hasn't been implemented. But in the meantime, we are together also with the Qt company on a good way of doing it. So there are ways of, so there are ideas of doing that either bare metal or with FreeRTOS, for instance, right?
Yeah.
Okay, so maybe we can go into an example from this hamburger menu.
I have here two examples, so I'll just move back to the Qt Creator, and here are few. So what we are doing here currently, we are creating a screen, but it's just red filled with a red color here, and this is a screen which doesn't have much, but it shows it's a red screen QML. So there is another screen is a green. It's just an example screen green, and its property there is a text inside, and there is filled with a rectangle, and there is also blue color. So there are the three screen. I would like to use now the horizontal scrolling for this. So what we have created here, come on, this is here the main interesting part. So if you see, we have no stack view or nothing available. It's a purely simple rectangle which we are using here, and in this there is just a title about the text, and yeah, and we can see here a rectangle we have created, and as I said, we have to use if we have to use the scrolling list, we have to use a flickable. So in the flickable, we have rows, and there is a model we have defined in the repeater where we are taking this red, green, and blue QML files. And this is being loaded, and we use the delegate, and we arrange them how we would like to have. So in the center, we are going to use these rectangles, and we have some property animation, which will be animating this rectangle. Okay, so yeah, and then we have interesting mouse area when you have click on particular element, so particular page it should land up. So all this screen definition is been done, instantiation is done here, and it's available, and few more navigation buttons we have added here. So back button and the mouse area and a certain logo, of course. So during the last webinar, you might have you have seen how to use the how to install the Qt for MCU, as well as how to compile the initial application. So I will not bore with that. So we'll just compile this application, and so I use STM32 ST-Link software, and so as you can see, this has been flashed on the screen. So now our red, green, and blue elements are available. You could scroll. So it's quite smooth scrolling available here. So this is how you can create a very quick application. So if you go to the red QML, so you can add your the red screen here, or the application screen, blue. So you can create a list with navigation. So this is a one part of the application, one application. So there is another application. We will shortly jump into it. So another point was another interesting how you're going to create a hamburger menu. So this is another example. So we have taken the same QML files, red, green, and blue QML file with content inside. And there's a hamburger menu QML, which is executed first initially. So wherein we have main background available, then we have some message information to where to click, and inside that nested rectangle, which explain about the header and some of the icons, and the mouse area defined where to click, and we are just making the other QML visible, the menu visibility we are enabling or disabling. So then there is more information about the header, and then we are creating the QML screens, and then we are walking through the rectangle where we set the opacity of the particular rectangle when we click on particular element, and this rectangle are shown here. So yeah, so if you see here, when we click on particular rectangle, we just change the visibility of other rectangle, other screens, and then we use this point to enable or disable particular screen. So let's compile this. And so I will use enablement. So this hamburger menu is available now. So we click. So we have, as we created on the left hand side, the rectangle, we have red, green, blue, and we can go to the main page again. So So when you click on this particular screen, you get exactly this same screen. So this is quite simple application, yeah, so which you can easily deploy by using Qt UltraLite. So these are the two examples what we have gone through. If you have any question end of the webinar, you can definitely ask, and yeah, we'll be able to answer to that. And in case if we are not able to answer, we will reply you on email. Yeah, so I will just share the presentation.
This is, yeah, it looks really performant on that small device, and having then a very thin Qt UltraLite application is also good. But how was then the porting from the original embedded UI Qt QML application, Qt file actually, towards that one? How did you do that? Was it then copy and paste, and you just went to the elements and you said, hey, so many the elements I need, etc. So just give us an idea, how was the process then?
Yeah, so as we were using the design studio, so yeah, so all our Qt elements were created in the so let me open the project, what we have done.
Yeah.
Okay, it's from this. So the basically what we have done, we have taken the existing QML code, and we saw what are the elements are not supported. We try to use those, update those elements by supported elements. So some of the elements were Qt types were not supported. So those particular types where yeah, just
how many how many percent of the code you have then used from the embedded UI to the UltraLite thing? How much of the code just by percentage has been reusable? So is that, can you give us an idea?
So approximately we have used most of the QML, we have used it, reused it, and certain elements we have replaced. And the replacement, I would say more or less 60 to 70% of we have reused the elements, and certain elements we had to change. So more or less, if you see here, the application remains the same.
Yeah.
And
this that's now the embedded, right? So that's the
that's an app what we have seen in earlier. So this was an embedded app. Now we have converted into MCU app actually. So yeah, the same elements are.
Sounds like you have achieved some some decent amount of work on that. So how long did you work on that? Just give us an idea.
Yeah. So
about how many screens we are talking here? Is it 15 screens or?
Yes. So something around 14 to 15 screen we have designed here, and what we could see is a lot of work from embedded application or the Qt Quick, standard Qt Quick has been reused here. So yeah, and particularly in terms of layouting, in terms of scalability, we have not changed anything. If you could see here, it says all the scalable properties what we have defined here. So
Yeah.
all these things were from as it is from the embedded application. So there were not many modification done for Qt UltraLite, but yes, certain things like hamburger menu, for example, list menu. So list, we had to do certain changes. For example, nested list, we had to go write a little bit about the modification, how to manage the nested list, and which was not available in the Qt UltraLite. So we had to do some modification into it. That was challenging. Plus, about the animation, as I was saying, some of the animations were not performant because due to we were using a lot many timers and a lot many property animations, and those animations we have just optimized it by using single timer, and we could see the immediate performance gain. So,
okay. And I understood also from the project that it was pretty much also an effort that could have been, or that has been split into multiple different chunks so that different teams could work on that, right? So everything was ready, but that you could have parallel work on that. So then by that, you can also speed up the development on that porting.
Yeah. So we just divided the work into certain elements. Some few members worked on the components, and some members worked on predominantly on the animation. So animation optimization, all that was the focus, and of course and the interactivity in between all these QML file was also played a role. And yeah, so
do you think so? Just if we speak about communication, right? So people, so this is just a bare metal implementation of Qt UltraLite. There's no operating system. If you think of having connectivity, so I'm pretty sure there are customers out there who would like to have also like MQTT or whatever, just network communication. Is that possible with as a bare metal, or would you also see other ways of doing that with FreeRTOS or something like that? And what would be faster, and what would be the difference from your perspective? Maybe as a final word from your end. We're having the expert here.
Yeah. So you can certainly implement MQTT and networking on bare metal, but the point would be you will not be able to manage multi-threaded environment. So it will be a simple a state machine where you get the message, you update the UI, so it will be very synchronized communication.
Yeah.
While so this is good for certain thing, yeah, definitely it works out for certain scenario. But if the application is little complex and you need dynamic update, then definitely one should move to the FreeRTOS or any RTOS system. So where you can use threads, task, a multi-process communication, and you should be able to achieve the same thing. So currently, as I said, we are implementing MQTT and network stack on the FreeRTOS, and the Qt is shortly available with FreeRTOS. So yeah, so definitely I think that would be really interesting to way forward.
What would this FreeRTOS thing? Just so I'm not the expert in that area. So what would that add as cost, right? So on the footprint perspective, for instance, is there much, or is that rather small?
It would be rather small, but the advantage, if you compare advantage running the multiple processes or multiple threads, I would say it will be much beneficial compared to bare metal. Yeah. So I have not seen much big difference between footprint in terms of with FreeRTOS and bare metal. So
Okay.
yeah. So yeah, sure. But if we
Thank you,
if
Ravi. So I think we need to, so we're running out of time a little bit. So Michele is certainly already getting nervous, and
okay.
we need to hand over.
Yeah. So I'll just share the screen. Hi.
So thank you, Ravi, for the nice explanation of what you have been achieving with Qt for MCU. So just a quick ramp up for all the evaluator, if they want to test actually Qt for MCU, you can download the online installer through our website. So just apply for try Qt for MCU on the Qt for MCU landing page, or if you have already a Qt account and if you have access to our Qt account online page, you just need to download the online installer directly from the online tool. And then once you get the online installer, what you need to consider is to basically install Qt for MCU package, because you will be granted an evaluation license as soon as you apply for a Qt for MCU trial evaluation from our website. And just a couple of words regarding our focus. One of our value proposition is providing to you as much as possible code reusage across different platforms. So you can reuse the same code not only on one hardware and MCU vendor, but across different microcontroller vendor. So right now we're focusing on the board are mentioned here on the slide, and you can already ask us if you want to try Qt for MCU on this kind of microcontroller. Please don't be shy and just reach out to us, asking us the binaries for those platform adaptation. We're working on other board, so we are keen to know which kind of project you are looking into, which kind of microcontroller you would like to see Qt for MCU supported. So please reach out to us and ask us more detail about what we can do for you. Right now, we are mainly focusing in different industries, so automotive, consumer, industrial. So all the major board vendor and hardware vendor and hardware platform we are looking into to provide support for that. So thank you very much for joining our webinar session on this time slot. Me or Lars, please feel free to reach out to us directly if you have a specific question regarding one of the topic we were mentioning today. So right now, I would like to leave you the chance to write more question on the Q&A session, so we can go on detail answering to your specific question. So one of the most common topic is if Qt for MCU comes with an open source license or if it's commercial only. So what you need to consider is that this is Qt, basically the Qt company project, and we decided to keep that commercial only due to the huge investment that's been done on the development of the engine, as was mentioned earlier. And as Ravi was mentioning before, another important item that is in our roadmap is the support for FreeRTOS. So what we are looking into is to enable you to basically run Qt for MCU on a FreeRTOS operating system, so you could manage also multi-threading with the Qt for MCU. And if you have a specific question that we were not answering right now, please just feel free to reach out to us on our contact us landing page.
All right, thank you everyone. Thank you to Lars, Ravi, and Michele, and thank you everyone for joining our live webinar session today and asking all of your questions. We will be ending the webinar soon, but if you have any questions on your projects, we are more than happy to answer them for you. You can contact us via our website at qt.io/contact-us, and we look forward to connecting with you soon.